Failure was never the problem. Misunderstanding failure was. People look at those endless rejection emails, those closed doors, and they naturally think interviews measure intelligence.
But they don't. They measure something far stranger. And the crazy thing is, hidden inside every single one of those rejections, there's actual information, but almost nobody sees it. So what have we been missing all these years? What's the actual signal hiding in all this noise?
Well, the grand illusion really begins right here. Most people, maybe even you at some point, believe that data science interviews are just massive tests of memory. You think you need to memorize Python syntax, perfectly memorize SQL queries, and drill the top 100 machine learning questions into your head. You hoard cheat sheets, right? Hoping that somehow, if you just cram enough raw information into your brain, well, success is going to inevitably follow.
But, as you'll see in this explainer, appearances are incredibly deceptive. Because here's the thing. Interviews are absolutely not examinations. They're consultations. When you treat an interview like a university exam, you're just answering a prompt. But when you treat it like a consultation, you are solving a real, breathing business reality. And trust me, that changes absolutely everything.
Let's consider the folks trapped inside this illusion. We can call them the strugglers. First, take Maya, the academic. She is undeniably brilliant, but she's completely paralyzed by her own rigidity. She leans heavily on formal proofs just to avoid the messy, unpredictable reality of a real-world problem. And then there's Leo. We kind of call him the script monkey. Leo codes incredibly fast. He hits 94% accuracy with just a few lines of imported code. But his foundations? They're dangerously weak. If the assumptions built into that library fail, Leo completely fails.
And the trap just deepens with Arjun and Sarah. Arjun, the career switcher. He came up from the warehouse floor. He possesses this deep, hard-won understanding of business logistics, but he suffers from cripplingly low confidence, mostly because he didn't study traditional computer science. And Sarah, the overthinker. She's got brilliant intuition, but it's entirely locked away by her absolute terror of being wrong. The thing is, these four, they represent us. They perfectly mirror the traps we all fall into when we start worshiping the tool instead of the underlying logic.
To break out of these traps, we really need a guide. So, enter Silas, the architect. Picture a wise, calm mentor who kind of operates on a different frequency. He never gives Maya, Leo, Arjun, or Sarah a direct, simple answer. Because let's be honest, direct answers are cheap. Instead, Silas teaches through first principles. He forces them, and by extension us, to look at the actual physics of the logic. And Silas doesn't start with complex math formulas on a whiteboard. He starts with the physical world. Think about the concept of bias. A struggling learner just sees bias as an error term in a complicated equation, but Silas shows them a steel rod. Bias is rigid. It's the heavy assumptions you force onto the universe before you even bother to look at the data. You say, oh, I always use this specific algorithm. Well, that's a steel rod. It's strong, sure, but if the real world doesn't match your rod, you're going to break.
Variance, on the other hand, is like a ball of yarn. It's entirely, almost chaotically flexible. If your model has too much variance, you're basically tangling yourself up in the highly specific history of your own training data. You aren't learning the truth, you're literally just learning the noise. So the magic, the optimal sweet spot, is finding the perfect balance. You need the rigidity of the steel rod to maintain your structure, combined with the flexibility of the yarn to actually adapt to reality.
But what about the human element in all this? Our ego and our fear. Silas frames these not as fatal character flaws, but actually as internal hyperparameters. Ego is essentially a mirror. It makes you try to force the universe to follow your specific, tiny history just because you desperately want to be right. Fear, though, is a locked box. It totally prevents you from taking the next logical step. You can't just delete them from your mind. But you must normalize your ego. Truly realizing the problem is way bigger than you, and you must apply a sort of dropout to your fear, completely ignoring the outcome of the interview, so you can focus only on the next line of logic.
Then, Silas takes them to the mountain to explain gradient descent. Imagine standing on a hillside, completely wrapped in soft, thick fog. You can't see the valley below. You don't have a map, nothing. But you can feel the slope of the ground right beneath your boots. If the ground slopes downward, you take a step in that direction. That is gradient descent. The gradient is simply your direction, and the step you take, that's your learning rate. You're literally using the slope of your own error to guide you to the lowest, most optimal point in the landscape.
But that journey down the mountain eventually leads to a quieter, deeper road, the data pipeline.
A struggling learner usually thinks data science is just the pristine lake at the very end, the beautiful ready-to-use dataset. But Silas explains the pipeline as a river flowing from the mountain all the way to the mouth. Every single station on this river is a chance for the truth to be either lost or found. Extraction is provenance, knowing exactly where the truth was born. Cleaning is your integrity. And monitoring? That's just watching the pressure gauges so your river doesn't run dry.
Because here is a genuinely terrifying truth about all this. A model can never be wiser than the road that brings it its data. If the river is poisoned right at the source, or if it picks up too much silt along the way, your model is just drinking mud. Never let a beautifully rendered output hide an unready input. You could literally have the most advanced neural network on the planet, but if your river is broken, that intelligence is nothing but an illusion.
Which brings us to the absolute climax of learning: backpropagation. See, learning always happens in two directions. The data flows forward, making predictions about reality, but the error? The error flows backward. The machine makes a guess, it looks at its residual mistake, and then it walks backward through every single connection to adjust its trust. It literally faces its mistakes to fix its future. And honestly, humans have to do the exact same thing.
This raises the ultimate contrast: the battle between the script monkey and the alchemist. The script monkey is incredibly brittle. The exact moment an interviewer asks, "Hey, how would you change the loss function here to penalize false positives?" the script monkey completely panics. They frantically search their memory for a parameter in some library documentation that doesn't even exist. But the alchemist? The alchemist simply steps up and rewrites the math, because they actually understand the mechanism behind it. Before the alchemist even touches a marker to the whiteboard, they perform what we call a Socratic interrogation. They use the 5 whys. What's the actual business goal? Who is the end user? If you just tell an interviewer that a feature is important mathematically, you've essentially told them nothing. But if you say it represents the friction a real user feels during checkout, boom, you've won. You absolutely must connect the abstract math to the human mechanism.
Then, of course, comes whiteboard combat. The script monkey treats the whiteboard exactly like a computer screen, rushing to write code, sweating over Python syntax, and just dying in total silence. But the alchemist treats the board as a canvas of thought. You aren't up there to just show them the answer. You're up there to show them your soul, to show your method. When you inevitably hit a wall, you don't frantically erase everything. You perform a first principle audit. You trace the logic back to exactly where it broke, and you invite the interviewer in. You pivot the whole thing into a collaborative solve. Because here's the secret. Interviewers do not expect you to be a flawless oracle. They're looking for a pragmatic architect who can actually negotiate through the chaos. A struggling candidate is absolutely terrified of uttering the words "I don't know." They think they have to provide this single, completely certain answer. But the alchemist knows the truth. Certainty is just a hallucination. Probability is the language we use to be radically honest about our own ignorance.
Imagine Silas slowly drawing a perfect, stark circle on the chalkboard. Inside the circle is your core logic. Outside the circle is the library. A library is just a convenience. But if you cannot explicitly explain the logic inside that circle, you have absolutely no right to use the tool outside of it. The strugglers have to take the vow of the alchemist. You have to strip away the jargon. Strip away the final result just to find the derivation. Remember, speed is a junior trait. True depth of thought, that is a senior trait.
Because at the end of the day, when the interview is over, you are being judged on just 2 things: the hammer and the heart. The hammer is your velocity. Can you actually build real value? But the heart is your temperament. Do they genuinely want to be trapped in a server room with you at 2 in the morning when the entire system is crashing? Technical skills will definitely get you the interview. But psychological intelligence, humility, and proving you're a collaborative teammate, that provides the peace of mind that actually gets you the job.
Picture Leo standing before Silas, chest puffed out, so proud. "But Silas, my model achieved 94% accuracy." Silas just gives this quiet smile and asks, "And what would happen if that accuracy completely vanished tomorrow?" Leo just freezes. Silas presses on, "Leo, if your understanding disappears the second the library disappears, did you ever really own the understanding to begin with?"
This right here is the systemic revelation. Data science isn't about the code. Machine learning isn't really about the libraries. Interviews aren't about having all the right answers. And failure? Failure is absolutely not the enemy. The real fundamental challenge is learning how to think. It's realizing that true expertise is a horizon. The closer you get to it, the further it moves away. To stay a master, you have to remain the eternal student. So as we wrap up this explainer, let's look at those closed doors one last time. Perhaps rejection was never a verdict.
Perhaps it was just feedback, a residual, a clear, undeniable signal telling you exactly what part of your understanding needs to be completely rebuilt from the ground up.
Perhaps interviews were never obstacles standing in your way. Perhaps they were mirrors, reflecting back not just what you currently know, but how deeply you are actually willing to look at what you don't.